So previously we made a dividing head attachment for the lathe. So this week let's put it and the vertical milling attachment to work. If you haven't seen the previous two videos, I've essentially replaced the tailstock with a dividing head. The goal here is simply to be able to hold parts in the lathe and also lock it in place and index it if necessary. And after considering making some sort of spindle lock or dividing attachment, I thought the easiest, most simple way to do this was to replace the tailstock with the dividing head, which I already owned. All I had to do was make a bunch of standoffs to bring it up to the correct height. The vertical milling attachment though is a bit of a different story. You'll see why this was necessary in a minute, but essentially all it is just some threaded rod, a linear rail which I stole from an old CNC project, and a bunch of 1/2 inch metal plate which I've simply welded together and then bolted to the new cross slide. It's not the most substantial piece of equipment that I've ever made, but given that it cost me almost nothing to make it and this is a one-off job, it'll do the job just fine. So I guess at this point, let's talk about the reason why I've gone to the effort to make all of these things. And to do that, we need to go over to the mill. Now something that I've said for the past 3 years is that one of the best things I did to this mill was stop using my Morse taper ER collet chuck and instead swapped over to what I call the quick change mill tooling. Essentially they're just ER collets with a 20mm shank and they're all held in a 20mm Morse taper 3 collet. It just makes changing out tooling a lot easier and a lot quicker because all you have to do is change the tool holder rather than having to undo the nut, change out the collet and change out the tool. The upfront cost is a little bit more expensive, but it is well worth it. Now whilst I do love this method of tool holding, the spindle wrench for holding the spindle in place whilst I undo the drawbar leaves a lot to be desired. Now I do want to point out that the method for holding the spindle whilst you undo the drawbar seems to vary a lot between different models and brands of milling machine. I've seen and used a few different designs, but by far the worst has got to be the one that they've used on this milling machine. Essentially you have a wrench with 2 pins and that locks into 2 small holes on the bottom of the spindle and you use that to hold the spindle whilst you undo the drawbar. In theory it should work, but in practice there's so little room between the bottom of the spindle and the top of the flange, and there's so little engagement between the pins and the hole that it's very easy for the pins to slip out and for the wrench to slip. And when that happens I can very easily hit my wrist on the tool. I can very easily graze my arm on the end mill depending on what type of holder, and I've also smacked my arm into the workpiece itself. Now I do want to stress that this isn't something that happens very often, but at the end of the day, this is just a numbers game. You know, I change the tool in and out maybe 30 times in a good project, so times that out and maybe say I have a slip once every 200 or 300 changes. You know, that does start to add up over time. Again, I don't get hurt every time, but again, it's just a numbers game and something that I really wanted to fix for a very long time. Now I think the most straightforward way of fixing this would be to add some sort of spindle lock. Essentially a pin that would locate into a hole on the spindle itself, and the spindle lock would be connected to either the milling head itself or the quill. Now adding a spindle lock would not only make the mill a lot safer to use, it would also make using it a lot more enjoyable because it also means that I don't have to worry about finding the spindle wrench because it seems to be one of those tools that I'm always losing. Now before I can add it though, I do need to get the mill pulled apart, just so I know exactly where the bearings are and how thick all the walls are, just so I don't accidentally drill into anything too thin or too important. Alright, so that's now the spindle and the quill now pulled apart. Unfortunately though, the news is not good. I was under the impression that the bearings sat a lot further down in the quill than they actually do. It had been a while since I'd pulled the quill apart, so whilst I didn't exactly remember what it looked like down to the millimeter, I did remember the model of bearing that I'd used. So going off its height and the height of that bottom flange, I thought that I'd have about 15 or 10 millimeters of space to work with. Unfortunately, it sits a lot further back than I'd remembered, which means the amount of usable space that wasn't being taken up by the bearing was about 3 millimeters. Now yes, there was more space at the bottom to mount some sort of spindle lock, but I wouldn't be able to use it because I need that space at the bottom for the spindle lock body. The original design needed to be as low profile and as compact as possible because the pin needed to lock into that flange on the spindle, and it also couldn't be lower than the bottom of the spindle itself, otherwise it would risk crashing into workpieces. So unfortunately, at least as far as my first design went, that was the end of that. Now after doing a bit of research online, I did find a few designs that use a pin that locates into a hole that's located closer to the center of the spindle. Now unfortunately, because I have a quill, it is going to complicate things a little bit because the quill also has to move upwards and downwards, which means I either cut a massive slot all the way down the side of the quill so I can use the spindle lock whenever I need to, or I can only use the spindle lock when the quill is fully retracted. Thankfully, I only use the quill when I'm drilling, and most of the time it is in the fully up position, so this shouldn't be a huge issue for me. So essentially what I'm planning on doing is having a spring-loaded pin that will go through the head of the mill, through a hole in the quill, and then lock into the spindle itself. Now that would be good, except at the moment, I don't currently have anywhere on the mill that I can install it. I can't really put it on the front because there is a really important alignment channel on the front that I don't want to interfere with, and I can't put it too far up because someone thought it was a great idea to install about 10 kilos of lead in the front of the head. I can't install it on the right hand side of the head because the handwheel for the quill is going to get in the way. I did think about remaking it with a different angle for the handles or maybe a different shape altogether, but I think there is a better way of doing this. Now unfortunately the left hand side isn't much better. There's the control box for the milling machine motor and also the handle for the quill lock. Funnily enough, there's probably even less space here than there is on the other side. But this is the side that I am going to choose because whilst I can't move the spindle lock location, I can very easily move the location for the motor control box. And by that I mean I'll just move it out of the way. It's only being held in by that plastic bracket, so I can easily remove that and just mount it somewhere else. So with it now removed, let's get it mounted somewhere else. I think the easiest way to do this is just to copy the arm and the mount that they use for the DRO. Essentially, I'll just make some sort of swing arm and mount it pretty much how they intended the DRO to be mounted in the first place. But instead of being a DRO, it's going to be a motor control housing. So the first thing I'll do is I'll quickly run up to Bunnings and grab a bracket and some aluminium extrusion, and hopefully try and make this work. Alright, so this is roughly what I'm aiming for, and hopefully this works. Now with the milling machine now fully disassembled, I'm instead going to crack out the drill press and use it to do all the drilling. I'm also going to drill 2 extra holes that will mount to the milling machine control box, and this will be so I can use the standard hole pattern to hold the bracket to the milling machine control box. Alright, and there you go. It looks a lot better than I thought it would. The important thing though is that it's opened up a lot of space above the quill lock. So the next thing that I need to do is get the milling machine head ripped off. Now once upon a time, this was not a huge deal, I could do it very quickly, but considering that someone decided to shove 20 kilos of lead in the milling machine head and also put a 20 kilo motor on top of it, getting it removed was a pretty big job. Now the next thing to ask is where to go from here. What I need is to get a hole drilled through the side into the quill and pretty much dead center into the spindle itself. And all 4 holes need to be pretty much on size and they need to align pretty much perfectly. And unfortunately, trying to drill straight into a curved surface can be, at the best of times, be pretty difficult. And of course, I can't use the milling machine to line everything up because the milling machine is disassembled. So here's the plan that I came up with. I first put the spindle back into the mill head. This is going to be without the spindle and you'll see why in a minute. I measured out and marked to the best of my ability the center line of the spindle. I'll now take it over to the drill press to do all the drilling. Now instead of using a twist drill, which isn't very strong and isn't very stable, I'm instead going to do most of the drilling, or at least as much drilling as I can, using a center bit. It's going to be a lot stronger and hopefully a lot more positionally accurate than a twist drill. Now unfortunately the center bit is not very long, but it was long enough to at least start that second hole. I'll then switch over to a twist drill and finish off the hole. I'll then open up that first hole with a Deming bit, and this means I can have a little bit of play for alignment later on. Alright, so far so good. I think those holes have come out looking really clean. For a little bit, I was a bit concerned that it was going to put up a little bit of a struggle because the spindle and the quill are hardened and tempered to the low 40s Rockwell C hardness. By no means is that super hard, but it did put up a bit more of a fight compared to a normal unhardened steel. Now the next thing that I need to do is get the milling machine spindle reassembled, and you'll see why in a second. And we can now finally take it over to the lathe and finally get some good use out of both the dividing head attachment and the vertical milling attachment. If it isn't already obvious, I can't use the disassembled milling machine to make modifications to the milling machine, hence why all these attachments were necessary. I also couldn't do this step with the milling machine spindle assembled with it in the drill press earlier, because the milling machine spindle needs to be completely locked, and as you'll see in a little bit, I also need to index it. However, before I can go any further, I am going to need to make a few modifications, because as it is at the moment, I'm currently clamping on that locking nut, and not the spindle itself. The lathe jaws just aren't long enough. And as you can probably imagine, that amount of run out just isn't acceptable for this type of job. So what I'll do is I'll take a piece of scrap aluminium and then bore out the center, until the center is the same size as the spline shaft. I'll then cut out a section to make it a clamping ring. And thankfully the run out is now a lot better than it was before. Now what I'm going to do here is I'll use the hole that we drilled earlier to align the drill bit for drilling the final hole. It shouldn't be too difficult because I know that hole should be perfectly perpendicular to the gear rack, so I can simply use a 1-2-3 block to make it perpendicular to the surface of the cross slide. With that now done and everything now locked in place, I'll use the spotting drill to mark out the location of the hole. Now I'm not going to be able to drill the hole all the way through because the spindle is still free to move, so I'll have to remove the assembly and get the spindle removed, remount it, and then use that marking which I marked out before to line up the drill bit for the final time. I'll now start to drill the hole. And with the hole now drilled, I'll now flip it and then drill the hole on the other side. Now originally I was going to drill 4 holes, but because I don't want to weaken the spindle any more than I am, I'm simply going to leave it as 2 holes. Alright, and that's the 2 holes now drilled. If you're wondering about the exposed bearing over there at the end, I am taking this as a good opportunity to replace both the top and the bottom bearings. I wouldn't worry about dust or chips getting in there because they're both being replaced. And with it now reassembled, it's now the moment of truth. I have some 6mm drill rod which I am going to use as the locking pin. And thankfully all the holes perfectly line up. Once I get it back in the mill head, it still lines up pretty much perfectly. So I guess so far, nothing's gone wrong. So with it now working so far, I'll now start to get it all reassembled. Alright, the final thing left to do is make a spring-loaded pin with a handle. And really, there's no need to overcomplicate this. I'll start off with a piece of 1045 steel and I'll drill a hole all the way through it. I'll then attach it to an arbor and then clean up the outside. I'll then get it in the mill and drill some counterbore holes for some M4 cap head screws. I'll now drill and tap some matching holes on the side of the milling machine. And thankfully with it now mounted, everything still perfectly lines up. I can now mark out the stroke length for the pin. When it's fully retracted, it can't engage either the quill or the spindle. And when it's fully pushed in, it needs to lock the spindle. Now to stop the spring from simply shooting the pin out, I'll drill a small hole and then mount a smaller pin in the center of the pin. And by pin, I simply mean I'm going to use a nail. Now off camera, I did taper off the end just to help it engage in the hole just a little bit easier. If my maths is correct, it shouldn't be engaging on that taper at all. The final thing I'll do is I'll take a piece of scrap aluminium and I'll make a handle to go on the end. And on the first go, it seems to be working pretty well. Now back at the lathe, I'll use a piece of scrap steel just to make up a plug that will go in that hole that was left by the bracket that held the motor housing to the mill. And with everything now perfectly adjusted, the mill spindle lock works pretty much perfectly. It slides in with very little resistance and it does a fantastic job at locking the spindle. And it's making my job of doing up and then undoing the drawbar so much easier. Honestly, I wish I'd done this a long time ago, and having only used it for a little bit, I can easily tell that this is going to be one of the best upgrades that I've made to the milling machine. All in all, I am really happy with this upgrade. The only thing that I do need to worry about, that I didn't have to worry about before, is that I need to make sure that I'm not engaging the spindle lock when I'm hammering on the drawbar to release the tool. It's not so much about denting the pin, it's more about preventing denting or damage on the spindle itself. So I think some sort of captive drawbar is going to be on the table at least sometime in the future. I'm not exactly sure about that yet, because I think to make a proper captive drawbar, it's going to require extensive modifications to the top of the spindle, at least on this design of spindle that I'm using. The opening of the spindle is a bit different to other spindles that use a captive drawbar, so before I do that, I need to think of a design that will work here. Now the final thing that I want to say is that after a few days of using this, I did make 2 further modifications to this design. The first thing I did was I hardened up the piece of pin that was going through that steel housing. The steel hole was rubbing up against the pin and starting to cut up that section. The pin was made from jewel rod and hardening it was very easy. And thankfully, with the pin hardened, there was no further problems. The final thing I did was blued up the puck just to make it blend in a little bit better. Outside of that, the spindle lock has been working with pretty much no issues at all. All in all, I am so happy with the upgrade, and it is easily one of the best upgrades that I've ever made. And with that, thank you very much for watching, I hope you enjoyed this video, and I'll see you next time.